Yes, thank you, sir. Good morning. Welcome to day 12 Arduino lab class. First, we will see the last class content for a few minutes. Then immediately we will come back to our ultrasonic sensor. Okay. Yes. Last class, we have seen how to interface the LDR. Okay. Using LDR, we have controlled the room light. So based on the light intensity in the particular hall, we have controlled the lamp in two ways. The first one, we made the light to on and off. This is simple on off control. Okay. The second one, what we have did, based on the intensity, we have varied the brightness of the LED. These are all the two applications we did with the help of LDR in the last class. So it is a light sensitive device. Based on the ambient light, it will give some analog value to our controller. From the controller, we can control the output devices. Okay, we have seen only LED. If you want to do some other control, also fan, light, likewise, can do any other appliance to control. Yes, now in today's class, we are going to interface the sensor. As are told already, we have 4-pin ultrasonic sensor as well as 3-pin ultrasonic sensor. In this class, we are going to see only 3-pin ultrasonic sensor. So what we are going to do, measure the distance of the object using ultrasonic sensor. So sir already explained how to connect the sensor with the controller, then how we are going to access the single pin for the input and output. So this is a little bit different from the earlier experiments, because the signal pin, for a moment of time, it is going to act as an input pin. After some time, it is going to act as an output pin. Then again, it will work as an input and output. So likewise, it is going to toggle from both the modes. What is the advantage of this one? Using single pin means the hardware size will get reduced as per the chip is concerned. Okay, now we will see how to implement that with the help of Tinkercad. Is it visible? Sir, is it visible, sir? Is it Tinkercad is visible?
Yes, Gajendran.
Yes, sir. Come to, so here already we have a Arduino and breadboard, and also we have powered the breadboard. Now we will check the components. Go to all. So whether ultrasonic will appear in input device or output device. Can anyone type it in chat box? From where I need to search whether ultrasonic sensor is an input device or output device. Can anyone type it in chat box? The name sensor itself implies input or output. Very good. Sensor means it is an input device. So now we will go to input and we will browse the component. So go to input. Yes, this is input. In this input, we are going to ultrasonic sensor. See, in the newer version, they added 2 types. Okay, in newer thing, now they updated 2 ultrasonics. Even though we are having 2, we will use with the 3-pin sensor. It is quite interesting.
கஜேந்திரன், நான் வந்து பழைய வெர்ஷன் தான் வச்சிருந்தேன். அதனால வந்து 3 பின் தான் இருந்தேன். சப்போஸ் நீங்க 4 பின் டெமான்ஸ்ட்ரேட் பண்ணாலும் 4 பின் டெமான்ஸ்ட்ரேட் பண்ணலாம் கஜேந்திரன்.
இல்லைங்க சார், இது காட்டிட்டு வேணா அதை அப்புறம் ஸ்ப்ளிட் பண்ணி
இது புரிஞ்சிருச்சுன்னா அங்க வந்து இது புரிஞ்சிருச்சுன்னா அது ஒன்றும் கஷ்டம் இல்லைன்னு நினைக்கிறேன்.
எஸ் சார், எஸ் சார்.
நான் என்னோடதுல பழைய வெர்ஷன் அப்டேட்டே பண்ணிக்கல, அதனால 3 பின் தான் நான் பார்த்தேன். ரைட்
சார், இது இந்த ஃப்ளோல ஃபர்ஸ்ட் போயிடுறேங்க சார்.
இதை முடிச்சிருங்க,
அப்புறம் வேணா அதை கனெக்ட் பண்ணி காட்டலாம்.
ஓகே,
எஸ். Yes, as per our discussion, whenever we are fetch any new device, we need to find the pin terminals. The first one, see, it is ground. The second one is power. The third one is signal. So we will start give the connection one by one. Please make a note of the pin arrangement. First one is ground. The second one is 5 volt. The third one is signal. And one more thing, whenever you buy the actual hardware component, that time the pin out may vary. Okay, you should not give the same way of connection. Before giving the hardware connection, you need to check your original hardware, then you need to start give the connection. Now we will take the ground pin first. Ground pin. So ground pin, I am going to connect it to the ground. then immediately 5 volt VCC. So if you see the sensors, the most of the sensors, the operating voltage is 5 volt, because you can say these sensors specially designed for to support the Arduino. Nowadays, Arduino compatibility is very much high, so they are designing most of the sensors for to support with the Arduino. If you are going for some other microcontroller, you need to do some modification in this, else accordingly you need to change your hardware unit. Okay, luckily most of the sensors supports with the Arduino IDE. Okay, now ground I have connected to ground, VCC I have connected to 5 volt. What about the signal? Signal, here I am going to use the 7th pin for my signal. No need, it is not mandatory all the time 7th pin. Here for today's experiment, we are going to use the 7th pin as our signal. That's all. The hardware connection is over. Hardware connection is over. Simple, only 3 terminals, ground, 5 volt and signal. Now what we need to do? As usual, we need to write the coding. Go to code part. Yes. Before writing void setup, let me type some coding in the global declaration as I explained earlier. So here I'm going to use the first variable as long. So long is nothing but it is a 32-bit variable. I'm going to store it in the particular variable. Integer means 16-bit value. Okay. Why I'm going to use long here means here I am going to measure the duration in microseconds. So the value will be little higher. So I should not the value should not overflow with the 16-bit value. For safe range, I am going to declare the value data type as a long 32-bit variable. So what I need to type here? First one, I need to measure the duration. Okay, duration. From where I will get, we will come back one by one. Okay, duration, first variable. The second one, hereafter everything will be in the 16-bit value because we are going to divide and multiply. So the second variable, what I am going to type is the distance in centimeter. Okay, distance in centimeter. Second variable, distance in inch. It is not mandatory. You need to have both the units. For initial stage, if you want to learn many things, that's why we included inch. See, in between, if you want to include feet, any other conversion you need, you can take it. But initially, what I'm going to do, I'm going to do with only centimeter. Then we will do the inch conversion. Step by step, we will go. Okay. Come to the void setup. Void setup is very simple exercise. Only one pin we are going to use it. So in void setup, can anyone type it in chat box which pin I need to use, and also at the initial state what is the mode of the pin? Very good. It must be a input pin. Input pin or output pin? Can anyone type it in? By default, what I'm going to declare? Many of them typed input. See, by default, we are going to give logic low signal in this pin. Therefore, what I'm going to do, I'm going to type the pin mode as pin number 7, comma output.
Also, the first thing that we have to give is trigger.
Yes, trigger. So many of them type, now they change, very good. Pin mode 7, comma output. Lovely. This syntax won't work if you exactly type in your program. See, the P must be small letter. Okay. Yes, very good. Pin mode 7, comma output. So immediately what I'm going to do, here there are two things. As usual, whenever you configure the pin as output mode, immediately you will keep it into low. And also, as for the application wise also, initially I need to give logic low signal for my given task. Therefore, I'm going to type it as digital write off pin number, comma low. Low I can give it in two ways. Either I can type 0 or I can type it as LWO. Let me practice 0 and 1s in this experiment. Okay. Yes. So what we did here, pin mode 7 comma output first is over, then we made it into logic low. Then you come to the second sequence. See, step by step we are going. Again, what I need to do after some time is after void setup will take some time to execute. After some time, immediately it will get enter into the void loop. At that time, what I'm going to do, I'm going to make the seventh pin as logic high. Seventh pin as logic high. Then how long I need to keep the my pulse? See, the pulse means always it is a short duration. It will not be a very, it will not be in a seconds or more than, always it will be in milliseconds or microseconds. Here our pulse, as are told already, as for the specification particular component, I need to give the triggering pulse for a duration of 2 microseconds. Okay, so 2 microseconds only I need to keep the pulse to be in on. So how to create microsecond delay? So delay, already we have studied, there are two type of delay available. Delay of, if I type any value in between inside this argument, it will consider as a millisecond. Here I need microsecond. So I will use another function called microseconds. Microseconds. What is the duration? 2 microsecond. Then what I needed to? After 2 microsecond, I need to make the pin to logic low. Then only the high to low transition you can detect. Okay. So now I am going to immediately after 2 microsecond, I am going to make the pin logic into logic 0. That's all. Can anyone tell what is the next step? Now we have triggered. Now we have supplied the trigger signal to our ultrasonic. Once it receives the successful signal, it automatically it will send some burst of signals. So 40 kilohertz it will send eight pulses. It will send. It will transmit. That sound wave will transmitted from the transmitter. If it hits by any object, it will reflect back. At that time, it will receive by your receiver. So during that time, what I need to do now? Can anyone type? I made the triggering successfully. After triggering, what I need to do? The same pin, as I told already, same pin will become logic high. Once the signal, the bus signal is transmitted, immediately the pin will become logic high. So what I need to do, I need to sense the particular pin. Therefore, to sense the logic level from the pin number 7, I need to change the mode immediately into what? Immediately into what? Input. That's all. So now my pin is in input. Now I need to check the duration of the pulse. I need to check the duration of the pulse. So duration of the pulse, very simple. Here you have an inbuilt function, duration. So the duration is nothing but, for that I have a syntax. Let me type the syntax first. That is called pulse, capital I in. Pulse in that I can pass 3 arguments. Now we will discuss only 2. Okay, what is that? What is the pin number? The pin number is what? Pin number 7. Okay, then logic level. What is the logic level? How long it will be in logic high state. Okay, that means whenever the pin become high, the duration, this pulse function will start count the duration. Then when it will terminate, it means whenever the pin become high to low, whenever your pin become high to low, immediately see this is my pin number 7. This is my pin number 7. Pin number 7. Now I am going to trigger for a duration of 2 microsecond. After some time, pin number 7 will become logic high, and it will be it will be in logic high. Whenever it hits the object, immediately it will give the signal as logic low. hits the object and returns back. Once the receiver receives this, it will become logic low. This duration I need to measure. For that purpose only, we are going to use that. For the purpose only, we are going to use the pulse-in command. So pulse-in command will start count from this logic high state. From this high to low transition, this duration will get stored into the particular variable. What is the variable name we gave? The variable name is called duration. So the pulse-in function will measure the duration in microseconds. How it will return? It will return the value in microseconds, not in milliseconds. Okay. Then now I got the duration. We arrived up to the duration. Once I calculate the duration, what I need to do? I need to do some conversion. I need to do some conversion to measure my distance in terms of centimeter. So what I need to do? What I need to do? So I need to do little calculation. For that, let me type distance in centimeter is equal to the duration. Duration is nothing but a t. In our formula, see, as per your formula, how to calculate the duration? Duration is nothing but, sorry, distance. The distance, as per our formula, distance is nothing but, let me type in comment line. Distance is nothing but time into velocity, isn't it? Time into velocity. I need to multiply with the velocity. This will give to and fro distance. So I need only the distance between the object. So what I want to do, I need to divide it with 2. This is the basic formula. I know the velocity of the sound, and also I know the duration of the time. With the help of this relation, I can calculate the value in centimeter. Okay. So I need to convert my duration. Here duration is, this is your time. So duration multiplied with velocity. Okay. So the velocity of the sound, I'm going to keep it as 0.034. Okay. 0.034 is the velocity of the sound divided by 2. So why it is 0.0343? It is in microsecond. Okay, the duration in microsecond. Then it is meter per second. All the conversions we have converted, and we arrived this into 0.034. Actually, the speed of the light is 343 meter per second. 343 meter per second. To convert into microsecond as well as the centimeter, we arrived this fraction value. If you calculate it by your own, you will get the same thing. So now I have calculated distance in centimeter. After that, I need to print my value in the serial monitor. So therefore, I'm going to initialize my serial monitor. Serial dot begin. Serial begin. The baud rate 9600. Now I want to print the variable. What is the print variable? What variable I need to print? Let me print the duration and distance in centimeter. Both the thing we will print. Okay. Serial dot print. Serial dot print. First we will pass one string. Okay. Duration equal to. Then only we will come to know the output value. Then only we can recognize our output value. Simply if you type any digital value, digits, it may not be understand for the user. So for that, what we are going to do? We are going to include one argument first. So first I am going to print the statement called duration, followed by the variable, followed by the variable. What variable? First we will print the duration. Then, so the duration, what is the unit of duration? Duration unit is in microseconds. Duration value in microseconds. If you want to give more clarification with your output, you can include it as a microsecond. Okay. Then what I am going to type? I'm going to type the distance. So distance. Let me copy the same thing. So distance is the another quantity we are going to print. So therefore, let me add one tab in between the previous one and this one. Then now I am going to print the distance in centimeter. Okay, distance in centimeter, distance in centimeter. That's all. Then this is distance, then followed by unit, followed by unit. What is the unit? We are going to type it in centimeter. That's all. Please go through the program. Please go through the program. We have declared the global declaration for few variables. One is duration, then distance in centimeter and distance in inch. Then void setup, we made the 7th pin as output. Then immediately logic low. Then we have initialized the serial monitor. Then in void loop, to generate the 2 microsecond pulse, we made the pin for 2 microseconds to logic high. Then immediately we made the pin to logic low. Then the same pin have 2 function. So up to this stage, it will be act as an output device. After that, it is going to act as an input device. Then we are going to measure the duration of the logic high. That duration in turn going to give the distance. So and also I'm going to print the distance in terms of centimeter. For that we did some conversions. Then immediately we are going to type. After some time, the loop has to continue. As I told already, after this, what I need to do, again I need to generate the triggering pulse. Again I need to trigger it. So for that, I need to include 2 more statements. So before continue the second cycle, let me give little delay for the first cycle. Then I'm going to again configure the pin mode 7 as what? Can anyone type it in chat box? Can anyone type it in chat box? What I need to type here? After some time, whether Danya it is input or output? Which one is correct? Input or output? Output is correct. Very good. So now I need to convert the pin mode into output mode. Then output mode. Then one more thing I need to do. I need to create a square pulse. Here it is logic high. If immediately it comes back, it will give only the high for 2. So it will not be in a pulse form. So what I need to do? Immediately I need to make the same pin into logic low. That's all. That's all. Do you have any doubt so far?
Basically, this is for fresh trigger.
Yes, again, trigger. Second trigger. Okay. Please observe the code. Shall we start simulate this one? Yes. Now we are going to simulate it. Yes. Just we will observe the serial monitor. Yes, we are getting 2 outputs. One is duration, second one is distance. Blindly it gives some value. Now we will compare with our this animation portion. Let me minimize little bit. Yes, this is our sensor. So I'm going to keep the sensor little low and I'm going to open the code. Wait a minute. Now it is perfectly visible. Okay, now see, as we told already, if you want to do any logical change or you need to give some signals to the sensor, the point is you need to click the sensor. Once you click the sensor, immediately the animation will get appear based on your sensor. Okay, here they given the animation, one certain angle is given as like a LDR. It is a bit similar to your LDR. Now I am going to, this is your object. You can move the object only in this portion. This is only the sensing region. If I bring the object beyond this, you will get some red indication. It is beyond the sensor range. It may give some other value. It will not be the actual value given by the sensor. Now, let me check the lower value distance, how much I can measure. See, this is the minimum value I can measure, it is 7 centimeter. If I zoom little bit, I can bring down little bit down also. Yes, see, 2 centimeter. Actually, sir told that we can measure the minimum range is 2, the maximum range is 3 meter. That is nothing but a 300 centimeter. Okay, so here, this is the minimum value. You compare with that serial monitor value, it is 2 centimeter. Now I am going to move the cursor little ahead of the sensor. Yes, see here. What is the output value I am getting? I am getting this 327. Okay, 329 I am getting. So if I move the object within the range, it will give the distance in centimeter. Please observe. And one more thing, here also they given some animation. They also printing the value. See here it is 157.3 centimeter. But as per our calculation, we are getting 155. There is a 2 centimeter difference between this animation as well as this, that you can calibrate with the help of any standard distance measurement. If you have any scale, you can calibrate with the help of the standard device. Then you can correct your value by using some multiplication factor. So if I slightly adjust this as, see, actually it is 343. If I include the fourth digit also, now we will check how accurate it comes. Now see, the error is reduced. Error is reduced among these two. If you consider this as a standard value, the error is 1.3 centimeter. Okay. So this is the one method how to print the distance. Do you have any doubts so far? Please tell. Else we will convert it into inches. Then we will make two more conditional statement. Okay. Do you have any doubts so far? Please type it in chat box. Else I will continue with the second portion. How to convert the centimeter into inches. See, here also they given two units. One is inch, another one is centimeter. Shall we try the inch? Okay, now we will convert the unit into inch. For that, what I need to do? If you remember the multiplication factor, can anyone type it in chat box? Actually, 1 inch is equal to 2.54 centimeter. That and all taken care, and SAR gave some multiplication factor. If you multiply with the fractional value, you will get the value in terms of inch. Can anyone type it in chat box? Okay, by the time, let me type the remaining steps of the program. What I need to include new here. So first I'm going to see, as per the animation, first I'm going to print the inch, then I'm going to print the centimeter. Let me take the copy of this. First I'm going to print the inch. So what is the variable we have used? Distance inch. First we will calculate distance inch. Can anyone tell what is the multiplication factor? Very good. 0.3973. Very good. See it. Even though it is an online class, yourself you need to maintain some notebook to note down the uh, theory content, because it is not possible to capture all the things in at a time. If you note down something, then only for future reference it will be helpful. See, now what we have did, distance centimeter, now I have converted into distance inch. Okay, by multiplying with this, the multiplication factor of 0.3937. What are the changes I need to do it for distance inch? Come down here, I am going to print it as distance inch. Okay, first duration, then distance in inch, then centimeter. Okay, that's all. That's all. Let me check the output. Let me clear the serial monitor once. Now you observe. Why two lines? We will remove this println here. Let me zoom the serial monitor. Thereby, yes. Now you observe. Now you compare these two. Now you compare these two. See here, inches 14 inch, but we arrived it as 13 inch. There is a difference in 1 inch. Okay, and the centimeter 35.7 centimeter. What we are getting is 35 centimeter. Let me change this one distance little far and check the output. The same error inch we are getting only 1 inch error. See, it is 60.4 inch. Whatever we are receiving is 59 inch. Centimeter 153.3. Here it is 152 centimeter. That's all. In this way, you can print whatever the unit you want. Before that, you need to convert the unit perfectly. Then you can start print this one. Okay, that's all. Though with this, the first task is over. Simply, we made one distance measurement unit with the help of serial monitor. Your today's task is you need to do the same thing in the LCD monitor. Okay, that we will show you last. What is your today's task? Before that, see, this is a one application. I can use this for distance measurement. The another application, as I told already, if I doing any parking application, or if I want to detect something, if any object comes nearby, it has to give some indication based on the distance between that target as well as the coming object. So let me type three conditions as are told: too far, too close, and safe distance. Okay, let me take this as an example. For that, what we are going to do, simply we are going to include few conditional statements in the same program. In the same program, I'm going to include few conditional statements. What are the conditional statements? Please make a note of it. If my distance, where is my distance in centimeter? Let me take the distance in centimeter. Distance in centimeter. If my distance in centimeter, let me zoom the screen a little bit. Yes, I hope. Yes, come down. Yes, if my distance is greater than 250 centimeter, 250 centimeter, I'm going to print the statement called, what I'm going to print means I'm going to print, simply I'm going to print too far. Okay, I'm going to print the statement called too far. Too far. That's all. Second condition. The second condition, based on your application, you can change these things. Okay. Else if my distance is less than 50, my distance is less than 50, I'm going to type too close. Too close means I need to take some action. Okay. Else it may hit my object. Then else 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 what I can do? Else simply I can type it as safe distance. You know the basic programming, how simple these things you observe. Okay. If you know circuits, you can recognize all the components. If you know C program, you can type the embedded C program. Likewise, all the prerequisites what you are studying will helpful in the upcoming stages. Okay. Let me start, run the simulation. Before that, we'll bring the screen. Yes. That's all. Now I'm going to start simulate the program. Why it is safe distance? Okay, let me type println. Wait a minute. We will type the status in new line, then only we can differentiate the output. Now you observe. Now you observe. Let me clear the screen once. So my distance of the object is not with. It is not. Now see, like I am going to keep beyond 250 and check. Okay, beyond 250. Beyond 250. See, it gives too far. Is it correct? 302 is the beyond 250, so it gives too far. Now I'm going to bring the object to in between stages. In between stage, it is giving safe distance. It is giving safe distance. I'm bringing the object less than 50 centimeter. What it gives? Less than 50. Actually, we made some mistake here, I think. Here we typed safe distance. See, it is greater than 250 means it will give far. If it is less than 50 means it has to print too close. For all other values, it has to give safe distance. Okay, let me check. Less than 50 alone, not giving exact output. We will check that one. Less than 50. What is the current distance? Current distance 55. So I need to bring down little. Too close. Yes, we got the output. Please observe, my distance now is 29 centimeter. Therefore, it gives too close. That's all. So likewise, you can do the command to print in the serial monitor, or else if you want any audio output means you can connect your buzzer and you can change the decibel of the buzzer based on your distance condition. Okay, even in a reverse parking, many of the four-wheeler you may have this same automation. If the target is very close, it will give a very high frequency alarm. If it is long distance, it will give a low frequency alarm. Like that also you can design your program. Okay, so this is regarding ultrasonic sensor with 3 pin. Sir, shall I continue with the 4 pin or what we can do, sir?
You have time,
Yes,
Gajendran. 20
yes
minutes
sir.
இருக்கு, முடியும்னா பண்ணலாம் Gajendran.
Yes sir,
அதுல வந்து
that we can.
distance எல்லாம் போட வேணாம், வெறும் measure பண்றது மட்டும் எப்படின்னு சொன்னா
Yes sir,
போதும்.
that we can do, sir.
Okay.
So, Karan, do you have any so far? Please type it in chat box. Thereby we will move to the other type of sensor, because that sensor are
That's
only
the most
readily
common
available in
sensor
market.
available.
Readily available in market. This is also available, not that much volume. Okay, if you find, you will get both. Yes. Now we'll do one thing. You will do with the another sensor. Not much difference. Okay, here we used a single pin for both the purpose. There are few manufacturers, they are giving individual pins. See, they are giving separate pins for separate action. See, if you compare this with these two ultrasonic sensor, see here it is VCC, then trigger and echo. In previous one, the single pin acts as a both trigger and echo. Here you are having individual pins. So here the program point of view, you can declare two individual pins. Accordingly, you can write the coding. So for that, what we are going to do now, I am going to replace the ultrasonic sensor with the new one. Simply delete and bring this. See, the pinout is totally different from the previous one. Okay, the first one is VCC. First pin is VCC. First is VCC. The ground is the last pin. The middle two are trigger and echo. So accordingly, I need to do the hardware connection change. So simply I'm going to move the wire to this pin and this pin. That's all. Then this VCC I'm going to move. Okay, now, so trigger separate pin, echo separate pin. So let me use the 7th pin as a echo and the 6th pin as a trigger. Same program logic, but we are going to use individual pins for. That's all. Let me keep it as some other color. Okay. So please remember, trigger is 7th pin. Trigger is 7th pin. Sorry, trigger is 6th pin. Echo is 7th pin. Come back to the program. Minimize the serial monitor window. So okay, let me use the integer, trigger and echo. Separate pins we will use. So trigger is 6th pin. Trigger is 6th pin. Then echo. Echo. Pin number 7. So accordingly, we need to do modification of program. So the first one, the trigger pin is always trigger pin. Can anyone type what may be the pin mode of the pin number 6? Pin number 6, pin mode of the pin number 6. Can anyone type it in chat box? Can anyone type it in chat box?
Very typing good. Output.
It must be always output. So what we are going to do? Pin number, trigger pin is always output. Trigger pin is always output. Okay, then immediately I will make the trigger pin to logic low by default. Then what about the echo pin? What about the echo pin? Echo pin is input. Very good. Echo pin is input. So echo pin, I need to declare it as a input pin. Once you declare, you no need to modify these things, because dedicated pins we are going to use it for individual functions. So trigger, then echo. Let me write the program in the same flow. First we are going to trigger, then we are going to deduct the echo. That's all. Now you come down here. So initially my trigger pin is logic low. So after some time, what I need to do? I need to make the trigger pin to logic high. How long it should be high? For 2 microseconds. After 2 microseconds, I need to make the pin as what? Logic low. Thereby my trigger part is over. Please observe, as for up to this, our trigger part is over. Then what else? Then whether I need to declare any pin mode inside the program? No need. I can remove this line because individual pins. Okay. Can anyone type where I need to measure the pulse in? Here earlier it was 7. Now what I need to do? In which pin I need to measure the echo? In which pin I will receive the echo? Very good. It is in pin number 6. So the pin number 6. No, not pin number 6. Who typed pin number 6? It's not pin number 6, I think. Everyone start typing 6. It is 7. Very good. It is pin number 7. Please observe. Echo pin number 7. Copy the echo variable and type it here. Now I need to measure the echo high. That's all. Then remaining procedures are same.
Actually, we are using two pins.
Whether we need these 2 lines, sir?
Actually, we are using 2 pins. One for trigger, yes. One for microcontroller output, one for microcontroller input.
Yes.
Trigger is microcontroller output, for that separate pin. Yes. The pulse is on the microcontroller input pin, that is echo pin.
Echo pin. Do we need to keep this 2 lines? No need. So we delete this one. That's all. So go through the program once. These are only the 2 things we included. Trigger is an output pin. Trigger is an output pin. Echo is an input pin. Okay, echo is an input pin. So therefore output logic low, echo input pin mode, serial monitor. Then this is a trigger portion, 2 microsecond pulse. After that, we are going to measure the duration of the echo. Then remaining calculations, then these statements. Okay. Now we will start simulate and we will check the output. Yes, by default, it gives the distance as 113. Okay, now what we are going to do, we are going to change the object distance. Let me keep the sensor little down and we will change the distance and check. This is the lowest distance I can keep. Please observe, it's 3 centimeter. Okay, it is 3 centimeter. The condition is as per our statement is too close. Now I am going to move the object little ahead. See the output. Now the distance is 133 centimeter or 52 inch. Compare with this animation also. Almost it is equal to this animation value. Now it is in safe distance. Now I am going to move the object for little away from the sensor. This is beyond 250 centimeter. Therefore, it gives too far. That's all. So in this way, you can use the ultrasonic sensor for a number of application. This is a non-contact distance measurement. We are not going to touch the object what you are going to measure. Therefore, you can measure many of the distances. Is a hazard any hazard objects you need to measure also. If you can keep your ultrasonic far away from the object and you can measure the distance. Okay.
Water level sensor.
Water level. See, sensors you can't immediately put it into water. If you put it into water, what will happen? Sensor will get damaged. So in those conditions, I am getting the isolation between my object to my sensor. No contact. Okay. So these are proximity sensors. Using these sensors, you can actually proximity sensor simply it will detect the presence of the object. The ultrasonic sensor is little advanced. It will give the exact distance also. Okay, but the range is you need to keep it in mind. It will vary from sensor to sensor. Here it is from 2 centimeter to 300 centimeter. 300 centimeter. That is nothing but 3 meter. And I will show you one more thing. If you bring your object too closer also, it won't work. See, now I come down very lower range beyond the 2 centimeter or 3 centimeter, but it will give some false reading. See, this is not an actual value between my sensor to the object. So minimum distance also you need to take care. Okay, if you are bringing the object too closer, it won't give the exact distance. That's all. So with this, the lab simulation portion over. So the task
Yes, Gajendran.
Yes, please take down the task. It's very simple. Using ultrasonic sensor, design a digital distance meter. So digital design distance meter means very simple. You need to sense the distance of the object. Here we shown the output in serial monitor. You use some display unit to display your output value. Okay, that's all.